Hey, code artist Howard here with our second video on the sequence portion of our introductory coding course here. It's looking more and more like I'm going to have to probably break this puppy up into a few more than 2 videos. We just have a lot of material to cover, and it's super important at these early stages that you get a good grasp, and I try to do that by providing a lot of analogies. So let's just jump right into it. What we're going to try to cover in this video are the way that we store data inside of a computer's memory, and we do that with variables and constants, and to some extent a technique called parameters as well. So we're going to also talk about the scope of those and how we mutate them and assign them value. So to use an analogy that I like to use with my students in my physical classes is you can think of a computer program as a way to solve a recipe. So here I've got a recipe from All Recipes for easy sugar cookies, and I love to use cookie recipes in my classes. So when you go through and you look at what the recipe is asking us to do, essentially what you want to do to write your code, and it's the same thing when you see the story problems that the customer gives you, or the book says write code to satisfy this problem. Essentially what you want to do is you pull the nouns out of the sentences here, and they become your variables, and then all of the verbs essentially become the methods or functions or subroutines of your program, whatever term you want to use for that. They're all the same thing. So in this particular case, we've got a simple recipe right here. I would say to you that there are no variables here. They're all constants, meaning they give you exactly the amount of ingredients that should be in here. So these are all going to be set as constants. This is going to be a constant also because they specifically tell you how high or how hot the temperature needs to be for the oven. And then these are also constants also. I would say min oven or min bake time and max bake time. They're already right there for you. So the one thing that I personally feel that is missing off this list is salt. So since the Stephanie person didn't put salt on here, I feel like I want to be able to add it. So I am going to add it to the program as a variable. Now, what I'm going to show you next is kind of a hybrid of pseudocode and actual code for the program, but for JavaScript. But I'm just using it as an example to show you how to take these requirements right here. And if you want to, go ahead and pause the video or print this frame out so you can kind of see what I'm talking about. But I'm going to have to move it out of the way so we can see the code behind the scenes. So here I've got our cookie recipe in a very simplistic JavaScript format. So up here is my standard section 1, here's my section 2, here's my section 3, and here's my section 4. So I went ahead and I took all of the constants that they had in the recipe, which was how many cups of butter, how many cups of flour, how many eggs, sugar, you get the idea. And I went ahead and assigned them the values that the recipe said. So now I've got that information stored in the computer's memory in an immutable way, meaning since it's set with the constant JavaScript word, these values are immutable. If I tried to come down here somewhere in one of my methods and change the value of fat cup, I would get an error message saying you're trying to change an immutable value. Immutable just means permanent or unchangeable for this program. Variables, on the other hand, are mutable, meaning you can mutate their values. Right now, the value that salt teaspoon is set to is undefined. There is no value. So it's not like it's a number or a string. There's no data type to it at all. It's set to undefined. So essentially what I've done in the computer's memory is I've opened up a box and I've put nothing inside of it. It's kind of like when you get ready to put your stuff away after you've cooked a meal and you've got leftovers. You pull all of your Tupperware out based on the different sizes that you need to put stuff in based on what you have left over from dinner, but you have not yet put any of the food inside of the Tupperware. That's what I've done right here in the computer's memory, is I've opened up a box, but we haven't put anything inside of it yet. Here I've created a box and put something inside of it using this special character right here, and a lot of people will see that and go, that's the equal sign. Well, when it's used like this, in this particular programming language, and in most programming languages, this is called the assignment operator. I am assigning this value into this box, and since I use the const keyword, it's immutable. I can't change it again later, so I've essentially taken a roll of packing tape and I've locked that box down and it can't be changed again. Now, I want to give you a quick word too on the different uppercase and lowercase things that you're seeing on here. This is called camel casing right here, where you take multiple words and you run them together, and the first letter of the first word is lowercase, and then every subsequent word is the first letter is capitalized. That's called camel casing. With constants, the standard convention is to make the name of the constant all caps and separate words in between with underscores. And the reason I'm getting these squiggly lines is because I'm not really using these down below anywhere, and that's what it's telling me. But there's actually an underscore in between these two words right here. And this immediately allows you to, it helps with your self-documentation to say, wait a minute, this is mutable, this is immutable. Okay. So now that I have all of the nouns of my program or my recipe done, now I have to come down and do all of my verbs. And so the rule of thumb that I give my students again is for any global variable that you have, you should have down in section 4 a method that mutates that variable right there and gives it value, and that's exactly what I have down here with set salt teaspoon. I say salt teaspoon equals how much salt do you want to add? And I would probably say something for a cookie recipe this size. I would actually probably say something like 2 teaspoons because I like my cookies a little salty. And then I have all of my other verbs that would have had instructions inside of here for my program based on what the recipe card said. This is the exact order of the directions. And then up here in my dispatch method, I now call them in the order that I want them to run in. And then here is my official call to my dispatcher, which then runs them. So to recap, we've got some casing here. We've got constants, we've got which are immutable, we've got variables which are mutable, and we mutate them typically down in their mutator method. And notice that this mutator method is cohesive, meaning it's only doing one thing. I'm just modifying or assigning value to what's in salt. And as another word on that, if I were to run this method call right here somewhere else, say down here below bake cookies, and I ran it again and I put a different value in there, it would replace the value that's in the box. Let's say, for example, I had 2 teaspoons in there and I decided for the next batch of cookies I wanted 1 because 2 was too much. If I typed a 1 in there, it would replace the 2 with a 1. That's what makes it mutable. So then we have our dispatch method. So that kind of talks about everything I wanted to cover for the variable section except for scoping. So what scoping means is anything that's globally assigned out here, globally declared out here, is visible by the entire program. If I were to create a small variable inside of right here, say down in here, and I would say let, because that's how we declare variables, is we use the keyword let, and I said num times, for say for example the number of times I'm going to check to see if the oven is heated, and I assigned it a value of 4. This is, not only is this perfectly legitimate to declare and initialize on the same line, which up here it is not. When we do things globally, we only ever declare up here. We do not initialize for variables. For constants we do, but for variables we only mutate in their mutator method. For local variables, like I did right here, not only is it okay, but it's desirable to declare, give it its name, and assign it all on the same line. And this particular variable, since it's only inside of this curly brace to this curly brace, it is only visible between this curly brace and this curly brace. Once this method runs and I leave, any of the memory that I opened up to store this value in, and if I made any changes in here to this particular value, that's all gone as soon as I hit this closed curly brace right here. So the reason that they say in our 10 commandments of programming, I'm going to throw another one at you, is prefer local variables over global variables, is because once you assign this value, or once you open this memory box simply by declaring it, it's open for the entirety of the program whether you need it or not. So if I only ever use this in one small portion of my code, I still have it open for the entirety of the program, which essentially I'm wasting space on the computer. What local scope variables do is once I open it up and I use it, as soon as I hit this closed curly brace right here, I recover all of that memory so that it's usable by the computer again. Alright, so we've got our mutable, immutable, and mutate down. The next thing I want to talk about are the data types of our variables. So with JavaScript, we have about 4 or 5 different what are called primitive data types. Although JavaScript is a dynamically typed language, meaning if I did let num times equals 4 right here, and then I did num times equals there, JavaScript is totally okay with dynamically reassigning this box from being a number box or integer, since there's no decimals, to a string box. And I know it's string because I've enclosed it in quotes. The different data types that we're going to work with in this particular class are number, string, Boolean, null, and undefined. So null is kind of a broken data type in JavaScript because it's actually an object type, not a primitive, but it's supposed to be a primitive. And null means the absence of any value. It's very similar to undefined. And I typically use undefined more than I use null. And you'll see it as we go through the code. But it's just a way of saying I've opened up a box like I did right here, and there's no value in it. So the data type of this right here is undefined. Number is pretty self-explanatory. It can be anything from an integer all the way up to a floating or a double or a long, depending on how big the number is and how many decimal places. And string is any variable that you assign something with quotes. And it could be numbers, it could be letters. But anything that you put inside of quotes and then assign it to a variable is a string variable, and it's interpreted as such. Boolean is simply a variable that takes one of 2 values, the word true and the word false. Very simply a way to say if something is true or if something is false. I still prefer to do numeric 0 and 1 when I do that instead of Boolean, but I'm weird like that. It's more self-documenting to me to do that, but when you see true false in JavaScript, just know that those are Boolean values. Alright, so I think we're looking at, what are we at right here? Looks like 14 minutes, so I'm going to call the video here, and then we'll have a third video where I think that's all we'll need, or 3 videos to kind of finish all this up. I'll have the actual code for this section up next so you can kind of see, but I hope the recipe analogy helped you out. Alright, thanks for watching, guys.